Good evening, good afternoon, good morning. It depends on from you are joining the program. Assalamu alaikum warahmatullah. Welcome to Big Bang Data Science Solution, week number two, session number. Okay, we have only one session, week number two, and this is our second week of the 10-week program of analytical project from zero to hero, or from the concept to completion with Python. So in the week number one, we learned about why you should become a data scientist. We talked about data explosion. We talked about what is data science, why data science, type of analytics. We talked about the data science portfolio, data science process, and the career in data science in case you want to switch the gear. Tonight, we are going to talk about business analytics and business understanding. This is a critical component, a critical ingredient for the entire analytical project. So we'll talk about a few topics. Of course, we are not going to have time to talk about all of this. So we'll talk about the designing a micro solution for any business problem using data. We'll talk about some of the other methods, but we will focus on one of the most useful or most used methodology in the analytical project, and that is CRISPDM. And we'll talk about all the phases, and of course, we will talk about the business problem. And next Friday, I am not going to be here. I will be traveling to Dubai to attend a conference. But my partner, it will be driving. It will be conducting the session. And next week, it is going to be an introduction to Python for data science. So we will simply touch base thing about Python. And it's not going to be enough for you guys, trust me. So you might need to, if you really want to jump into data science, you need to invest time-wise, effort-wise, and money-wise to learn at least one programming language, either R or Python. It's totally up to you. To prepare for that, I want you guys to download. I want you guys to download the Anaconda. Yeah, so I want you guys to go to www.anaconda.com. So this is the program that we are going to need. And Samia, we don't need your camera. Please shut off your camera. Yeah, please go to anaconda.com. So click on download. And it depends. It is going to read. It is going to determine, the your operating system. So mine is Windows. So simply click on download, and you should be able to download it. It's very simple. And once it's downloaded, and simply install it. It's straightforward. Just keep pressing next all the way to the end. And if you have problems installing the Anaconda, the Jupyter notebook through Anaconda, please reach out to me through the program and not through the week. You can reach me out through the WhatsApp or the Canvas, or email me. Okay, so let's jump into the lecture for tonight. Okay, so we'll be learning a few things. We'll be learning a few things tonight. We'll be learning understanding the problem, understanding the business, how to frame the problem, understanding the CRISPDM, and of course, if we have time, we are going to do an exercise. So that is the plan for tonight. So let's, in the analytical project. So we'll talk about the CRISPDM. CRISPDM is a methodology. It stands for Cross-Industry Standard Process for Data Mining. It's a methodology that it's been used in the market for many years, and it's been successful is a methodology that you use to monitor your progress from the start of the project all the way to the end of the project. So you will be working on for a project, or you're working for someone on a project, and honestly, most of the analytical projects they are designed to help a management, or to help someone, or to help the company you are working for make a better decisions. So in terms of making better decision, there are three teams. There are three teams of making a decision on a client, making a decision on a price, making a decision on a customer, on a patient, on a product, on a service, on so many things. So when we are planning to make a decision analytically, so we are thinking about three teams. So number one, we are talking about the framing a decision. So the first thing that we need to do is we need to frame that decision we are trying to make. And framing decision is simply a phase that where you need to spend time understanding the decision itself, understanding your client, understanding your objectives, understanding your customers, understanding the problem, understanding the requirement. That is called framing a decision. And of course, acquiring the data and understanding the data itself. Then the second phase, or the second theme, is called analyzing a decision. This is where now we have a good understanding of the problem, a good understanding of the data, and it's time now to analyze this data to try to find a smart and automated and intelligent solution to the business problem that we've been hired for. And if everything goes fine, then it's time to implement that decision, implement that production, implement that solution into production. So there are three themes: framing a decision, analyzing a decision, and implementing a decision. To apply these three themes, there are many, many methodologies that you could use, and one of them is called CRISPDM. So before we talk about CRISPDM, if in the data modeling, we are talking about machine learning. To build a machine learning solution, to build an analytical project to complete or conduct an analytical project using machine learning, or using scientific method, or using, in data science in general, you are going to need four ingredients. You are going to need four ingredients. If one of these ingredients is missing, most likely you are doing something wrong. The first thing you're going to do, you are going to need is data. Of course, as we talked about last session, is data science is all about making decisions or using the data. We that does not mean we are. I mean, it's substitution to making decisions using experience or using intuitions. It is simply using data. We can still use our experience, our own experience, or our way of thinking, but we want to make a decision using the data. If there is no data, there is no machine learning, there is no data science. So that is the first ingredient. And this first ingredient, it has to be in a shape. It has to be in a format that is suitable for analytics. You cannot simply analyze the data that is dirty data, data that has a lot of problems, a lot of missing values, a lot of outliers, duplicates, data that is inconsistent with others, data that is simply a raw data. So we have to bring this data into a format that is suitable for analysis, and we are going to go through that. And this data can be anywhere. It could be in the cloud, it could be in the databases, it could be in flat files, it could be anywhere. And your job as data scientist or data analyst is to get out of this data that is everywhere within the organization, get what you need for your analytics. Malik, please go ahead and meet. Okay, so that is the first ingredient. The second ingredient is we have to use a model. And of course, we are going to learn modelings. And in models, there are four types of modeling. Supervised learning, supervised learning, when we have something to supervise your learning, when you have something that your base your savvy, and that is what we call target variable. So when you have a target variable that you're trying to investigate, that is called supervised learning, and we are going to cover that in the program. And in supervised learning, we have classification and we have regression. In classification, when you have a target variable that is either a binary, 0 or 1, or trinary, or multi-class, or nominal. Regression, when you have a continuous target variable. So that is supervised learning. Semi-supervised learning, when you have a data, part of it has a target variable and the other part does not have a target variable. Then we have unsupervised learning, when you don't have a target variable and you have then finally we have reinforcement, when you don't have a data. All this type we are going to talk about them, but in brief. In this program, we are going to learn classification, supervised learning classification. Unfortunately, we won't have time to cover everything. So we have a program that runs 5 times a week, 3 hours per session for 8 months. If you want to learn everything, my recommendation, if you have time, you have energy, to join the program, which is going to start in August. We are running one program now, but now we are in week number 10. It's going to be, it might be too late for you guys to join, unless you want to join, and of course you can still join if you want to. But there's a program that's going to start in August. It's going to cover everything, that most of what you are going to need to become a superhero data scientist. So the first gradient is data. The second is models, and under classification we have decision tree, we have random forest, we have logistic regression, we have naive Bayes, we have artificial neural net, we have bagging, boosting, stacking. We have many models that we can use. Many models. So under each direction. So that is what second ingredient. The fourth ingredient is what are we trying to do? What are we trying to do? Are we trying to explore?
Mo, sorry, can I ask you a question or should we hold until
Please hold
later?
on. Yeah, please hold on. I'll let you ask a question.
Okay.
Then block number 4 is what are we trying to do? So if you guys remember, we talked about the 4 type of analytics. We talked about descriptive analytics, predictive analytics, diagnostic analytics, and prescriptive analytics. There are 4 types. Actually, there are 6 types of analytics. The most common one is prescriptive, descriptive, diagnostic, and predictive. There are another ones called 2 more, simulation and optimization, but those that are used when you don't have a data. So we know what we are planning to do. The only ingredient that is missing is something that we need to discover from the data itself. So this is what we need to get out of analytics, is find some hidden patterns, hidden mathematical equation, mathematical relationship, mathematical correlation, mathematical signals. Even though we don't have to deal with math, it's all math. So these are the 4 ingredients you are going to need to build a successful analytical project, regardless of the industry you are working for, regardless of the company you are working for, regardless of the data that you have. Yes, sir. Someone had a question?
Yes, thank you. So in terms of building the model, right, are there tools that allow you to build models, or do we have to use our own knowledge and experience to build these models?
There are there are a lot of tools. There are a lot of tools. Some of them they are licensed, some of them they are applications, and some of them that you need programming like R and Python. But honestly, if you were to become a superhero data scientist, then you need R and Python. There are 4 ingredients that you are going to need to make a prediction. You are going to need the data, and the data has to be in a certain format. You are going to know what models you are going to use. There are many models. Depends on the type of analytics. There are models for classifications, models for regression, models for reinforcement, models for supervised learning. Then, of course, what are you trying to do? Either you are doing prediction or descriptive analytics, predictive analytics, diagnostic analytics, or prescriptive analytics, or optimization and simulation. So the only missing part is the hidden parameters or hidden signals that you as data scientists, you as data analysts have to discover from your data. In terms of the methodologies, we have to have a plan. We have to have a methodology. So there are a lot of methodologies that you can use. You could use the scientific method. You could use delta method. You could use the IIE method, math scales method. But the most the most used model is called CRISPDM, and it stands for Cross Industry Standard Process for data mining. Data mining means data science. Okay, so when you are planning for designing, when you are designing a solution for any business problem, if you have a data, of course. So two things that you need to think of as number one, the micro methodology that you need to use. What is the micro methodology? How you are going to conduct your analytics end to end. You have to have a methodology. And as I said, there are many methodologies, scientific research method. And in this scientific research method, you start with a question that you need to research. Then you state one or more hypotheses. You examine and refine the hypothesis, investigate and collect data, analyze. So this is one method, but it's been used, but not in analytics. Another method is called operations research method. A third method is called the waterfall method, where you gather the requirement about the business problem, and of course you'll be working as a team. Then you design a solution, you implement that solution, you verify that solution, then you maintain the accuracy of that solution. But the most needed or the most used methodology is called CRISPDM. In CRISPDM, it's phases. Phase number one is understanding the problem, understanding the business. So we need to make sure that we understand the problem, understand the business, the right, and the way that the management and the stakeholders understand it. You just been hired today as a scientist. Of course, there is no way you would understand the problem, you would understand the business, in one day or even in a month. It's going to take you forever to understand every bit about how the businesses are running. So we need to understand the business problem. We need to understand the business if we were to design a solution. If you misunderstood this critical component, of course, what comes after it is simply a waste of time and effort and energy. So once we have a clear understanding of the problem, then we are going to move into data. And of course, we need to spend time understanding this data. What is that we have in the data? How is the data? What is the shape of the data? What is the structure of the data? How is the quality of the data? Do we have any problems within your data? Do we have any missing values? We need to find them and fix them. And there are many ways to fix them. Which way is the best way to fix them? Depends on the data they have, depends on the problem you're trying to solve. Do you have outliers? Do you have duplicates? Do you have categorical data? So once we understand the data, of course, we are going to fix it. We are going to prepare it. We are going to pre-process it. We are going to bring it to a shape that is ready for analytics. You cannot simply jump into your data and start analyzing it. It's garbage in, garbage out. If your data is garbage, most likely you are going to design, you are going to implement, you are going to have a garbage solution. And we don't want that to happen. So once you have the data ready, now we are going to build models. We are going to build a model. We are going to evaluate. We are going to build as many models as we want. At the end of the day, we are going to keep only one model with the highest accuracy. And that one model, there is always rooms. There is always rooms for improvement, for optimization, and for tuning. That is called model optimization or model tuning for for short. And if everything goes fine, then now we are going to deploy the model into production. Now it's time to put this model into production, and it is going to do your job. So imagine that you work for a bank. You work for a bank, and your job as data scientist is to in your daily basis you are dealing with applications, loan applications, thousands of applications every day submitted online or physically for clients trying to get a student loan or mortgage loan or car loan or whatever loan they are trying to get. And your job is to go through these applications and approve or deny. So if you were to get 5 applications on the first day, you can manage it. 10 applications a day, you could manage them. 20, you could manage them. Imagine that you are getting 100 applications every day. So what you have to do, you have to hire a new employee. Then what if you are getting 500, then you need a third one. 1,000, you need 10 employees. And imagine that you hired 10 employees full time. Then next month you get only 5 applications. What's it gonna, you just know you are wasting your resources. You are hiring 10 employees. You were expecting to have more than 1,000, but you have only 10 applications. Of course, you have 2 options: either to fire them, or you don't know what's going to happen tomorrow. Tomorrow you could get 5,000 applications, or you keep them. You don't know what's going to happen tomorrow. Tomorrow you could get only five applications. Either way, it's a nightmare for you as a business. So what is the solution? Is instead of hiring employees to approve or deny an application, we could design an algorithm that does it for us. And this algorithm runs for one application and for 500 million applications per day. We can do that. And that is when we implement that model or that solution into production. The moment you log in to our website to submit your application for all the paperwork for requesting a loan, of course you are going to get an instant approval. Yes or no? Yes, and once it says how much you deserve, is it 5,000, is 500,000? If it's no, we need to give you an answer why your application has been rejected. That is what this data science is bringing to the table. Okay, so once we learned about the macro methodology we are going to use, and most likely it is going to be CRISPDM. That is the macro methodology. That is the process we are going to use to be able to monitor the progress and the growth of our analytical project. The second thing in the process is thinking about the micro. So within CRISPDM, there are a lot of micro little things that we need to do. What do we need to do? Either are we planning simply to explore and discover, simply applying what we call descriptive analytics, simply trying to find, understand, discover, explore what has happened in the past. That's all we're trying to do, applying some business intelligence, trying to figure out or find out what happened. That is called exploration and discovery. And this exploration and discovery, it does not really require any modeling. You don't have to use a modeling. Sometimes, yes, you do. But all what you need to do for exploration and discovery, you could use data visualization. You could use data analytics. You could use descriptive analytics. You could use also statistical analysis. All what you need to know: the mean, median, mode, standard deviation, then the distribution. You could get something. So once you determine the micro methodology, then within that micro, you need to determine your micro is simply you need to scope down your analytics. So if you were to do exploration, you don't have to do, probably you might not need any machine learning. So second thing is you might need to build a solution that is dependent on the data. A solution that is dependent on data, a solution that requires data. And that is what we call machine learning. In most machine learning, they require data. Sometimes you are going to be building solutions that are not independent on data. I'll give you an example on a solution that is not dependent on data. Imagine you are working for UPS. You are working for UPS, and you are working in a very small. And you are a UPS driver, and you are working. And you have one what you call it, a region that you are that you work on. So in that region, in the area, you have 1,000 package to deliver in one day, and of course you got houses everywhere. So there is no data, but we want to design a model, an efficient model that is gonna. So we got 1,000 packages to deliver to all these clients, but we want to find out which is the best road to take that would save us money, effort, and time. Can we go like this? Yeah. Can we go this direction and come back? It could be. We don't know yet. So we need to build a model, a solution that is not dependent. Data is not required, and this is not. This is out of the scope of the program. So we are going to build a model. We are going to build solution using exploration and discovery, and we are going to build models that are dependent on the data. So exploration, models or solutions that using exploration and discovery. As I said, you don't have to use machine learning. Simply use statistics, experiment and design, sampling, hypothesis testing, linear programming, ANOVA, MANOVA. There are a lot of techniques that you could use, and you could get something beautiful for the business. And we are going to see an example later in the program. Or you could do, if you were to use solutions that are dependent on the data, these are machine learning. We could do cluster analysis where we didn't have a target variable. Regression analysis, we have a continuous target variable. Classification, we have a binary, trinary, multi-class target variable. Time series, graph, time series, neural net, factor analysis, general linear modeling. There's a lot of modelings to use. So, but the future, I will tell you, this is my own opinion. If you really wants to hit the rock, as they say in this data science, so concentrate on either NLP, natural language processing, or computer vision, or graphical analytics. One of these three. NLP, natural language processing, and we have a program. As a matter of fact, we just completed a 10-week free program for NLP, and I have all the videos available on YouTube. Yeah, please go with reach out to them. I'm sorry, go watch them and take notes. If you need help, let me know. We could schedule a one-to-one session to clear out any doubt that you might have. Computer vision, I'm designing another 10-week is going to be free. but I don't know when, but it is going to be free. And graphical analytics, it's too far from now. So that is exploration, discovery, simulation are solutions dependent on the data, and finally solutions are independent on data. This is heavy math, heavy programming. It is out of the scope of the program. I am not into this. This is not my area, and I wouldn't recommend going that direction. But it might end up going there later once you master the solutions using the exploration and discovery, and solutions that are dependent on the data. Any question, concern, please? Any questions, concerns, please?
Mo, what does mean NLP?
Natural language processing. Natural language processing.
Brother Mo, are you going to share the link to NLP videos?
Yes, sir. Let me do that.
Jazakallah.
Yeah, it's called natural language processing. And let me know if you need if you want access. I can give you access. No, just reach out to me. I will be more than happy to give you access. So this is it.
Okay, I'll do it.
NLP. What is NLP? Yeah, this one. So I got a lot of, and also if you are,
I would like the lessons too.
yeah, please, just you have to contact me through WhatsApp, and I will give you access. I need your email. Just send me your email through WhatsApp, your full name, your email, and I will give you access. And if you are an Arabic speaker, I have the 15 weeks free program teaching data science in Arabic, and everything is on my we call it YouTube. Just go to YouTube and search for Midwani. Search for Midwani. Yeah, and there's a lot. And at the same time, I'm gonna
one of the product I came across. So what the product does is basically captures the data from every single workstation in an organization, and it basically records like what's a typical the IO usage of a given system. Like I'm using my email on daily basis, browsing on a daily basis. On a given day, like when that particular workstation does much more IO. For example, like that given employee wants to try to upload that huge GBs of data to the external site, or just to does something which is an unusual, that particular workstation and person is getting highlighted, right? So they are, like, product are really claiming that they are the AI and ML behind. Like if you have to really map and such product back into the methodology, can you just highlight like where this basically this example fits into your previous slide? Like obviously this solution is based on the data, but within, I think we have like about 5 to 6 classification, like where we can fit this particular problem into the learning here.
Sure, brother. So
yeah, I was saying, are we going to do an exercise to see, or come down to the best model? So if we have a lot of data, how do we determine what is the data that we want to keep and what is the one we want to throw out of the window? How do we find one?
Yeah, I mean the first week of the program and the second week of the program is simply an introduction to the program. Starting from week number 3, we are going to move into coding and into a real problem. Okay, so through that real program, we are gonna learn how to understand the problem, how to understand the data, how to prepare the data, how to build many models, how to pick one model, and how to deploy a model into production. But if you have a project, if you have a real project that you want us to work on, please share it with me. I will be more than happy to use that project as an example. Okay, folks?
Thank you. Thank you, Brother Mo.
You're welcome. Okay, so we talked about this is CRISPDM as I mentioned, and this CRISPDM is phased. We start as usual with business understanding, then we move into data understanding, then we move into the data preparation, and the modeling, evaluation, and the deployment into production. Okay, as you see, we have some, this CRISPDM is feedback loops. CRISPDM in feedback loops means you are welcome to go back. So if you are in the modeling and you are not getting what you are supposed to, you are not getting what you are expected, so you might need to go back instead of giving up. Go back and probably check all the transformation method. Check what you have done with your data. Probably you did something stupid. Accidentally, you deleted something you are not supposed to delete. Accidentally, you kept something that you are not supposed to keep. Accidentally, you applied the wrong transformation method, so you got the data in wrong format. So if that did not help, probably go go back to data. Maybe you misunderstood the data. Maybe you did not collect enough information, enough data. Maybe your data is wrong. So if that did not help, then go back all the way to the first phase. Maybe you misunderstood the entire process. So always you need to go back and fix what needs to be fixed before you get into the point that is going to be too expensive. Once you get into the evaluation, I think it is going to be too expensive to go back and fix something to be fixed. It is going to be too expensive. It's always good to fix what needs to be fixed at an earlier stage. It's you can go back very easily, very quick, and continue rather than waiting all the way to the end and you find out that is you're wrong, your data is wrong, your analytics is wrong. Then it's going to be very expensive to fix that. You might end up losing your job. So that is the CRISPDM. So with details, I'm gonna switch to today's session. So in details, so this is the CRISPDM with much more details. This is something I myself designed for my students, and they have been using it since 2014. So in the first phase, which is business understanding, during this phase, you need to determine the objectives. What are the objectives of you conducting this analytical project? You have to understand the objectives. You have to know them. Then you have to frame the problem. You have a problem, and that problem could have many directions or many ways to solve it. So we want to get to the best way of solving that problem using analytics as using the data, and that is called framing the problem. So for one example or one problem that we are handling through the 30-week program is an auto insurance problem. So this auto insurance company, they are losing too much money because of the fraudulent. They hired us as data scientists. They provide the problem, they provide data, and they want us to fix it. So the problem is, instead of having an investigation team that investigates up to 30% of the entire claims, the business is still losing money because of the fraudulent. This is called problem statement. Your job as data scientist is transform this problem statement into an analytical problem, into quantifiable problem, by simply breaking it through, framing it into small pieces. So to help the business save the money or fix the fraudulent problem, you could, as data scientists, analyze the claims, you could analyze the client, you could analyze the payment, you could analyze the process, you could analyze so many things. You could analyze two things at the same time. So you need to frame, you need to find what needs to be analyzed, within, to be able to solve the problem. Then you need to define the measurement. Defining the measurement is very important. At the early beginning of your analytical project, you need to know how would you determine if the project, once finalized, is successful or not successful. So we need to have some measurement. The business needs to provide some measurement that we can use to determine if the model is successful or not successful. And of course, if you know that you are going to be applying the predictive analytics. If you know that your analytics is predictive, means trying to predict the likelihood or the probability of something to happen, then we are going to need one variable. We are going to need to know what variable to investigate. And that variable to investigate is called Y variable, or it's simply called target variable. And of course, we need to identify the analytical approach. Are we planning to do descriptive or predictive or diagnostic or optimization or simulation? And of course, we need to determine if we are going to deploy the model. Sometimes it will be hard for an analytical project to simply give the business information. There is no need to design a solution to deploy it into production. Just give me who is most likely to leave. Give me which state is more profitable than the other state. Give me which product should be launched tomorrow, which product we need to take out of the market. Just give me some information. It does not require implementation, but some models, some projects that you need to that require implementation, acquire deployment into production. If you know that the project or the model that you are working on requires implementation, you have to plan for it. Unfortunately, 80%, 70% to 80% of the entire analytical project fail, either because we misunderstood the problem, either at the beginning, so we misunderstood the problem, or we did not plan for the end. We did not plan for the end. Imagine that you've been hired for this bank, design a solution that approve or deny application. You got everything in there correct. You tested the model, everything looks fine. But when you come to the implementation, there is no instructor in there. There is no one to help you deploy into the production. There is no one with the skills needed to make it happen. So we have a solution, but it's useless because we did not plan for it from the beginning. And that is going to be fail. It will fail regardless of how great the project is. If you cannot use it, then it's fail. So of course we have to have a plan. We have to have a start date and end date, and also we need to know the stakeholders. We need to know stakeholders is anyone with interest in getting the problem solved, and we have to have a team. Data science is a team project, is a team sport. You have to have a team. Having a team cost me a project in the past. I was hired by a friend of mine working on a project. I was so excited, and guess what? He asked me, the first day asked me, how long does it take you to fix this? I told him, by the end of the day, I'll have a solution for you. And within 3 weeks, I am still struggling, trying to understand the data. 3 weeks. Why is that? Because I was working on a project on myself. I didn't have anyone to help me with the problem, no one to help me with the data. Simply, all I have is some knowledge, some experience, and playing with the data. And I wasted 3 weeks, and guess what? I lost my job. So we have to have a team. If you don't have a team, just prepare to hear the music later. You have to have a team. And in this team, we have to have 4 expertise. In the team that you are working on, we need to have someone with the domain expert, someone who knows the business better than you, someone who has the knowledge domain knowledge, someone who can help us drive questions, know the business, find assumptions, help us gather the requirement. And of course, we are going to need someone who knows the data, database, data expert, someone who can tell us where the data is, how the data has been selected, how the data has been stored, where the data has been stored. He can help us with collecting the data, explaining the data if needed, addressing any concern we have about data, and also answering any question that you might have on the data itself. So we have to have a data expert. And of course, we are going to have you. This is you. We are going to have a data scientist or data analyst, and we are going to have a manager who manages the entire team. My job is to work to solve problems using analytics, and I don't have time to try to figure out how to access the data. I don't have time to try to find out who do I need to interview or talk to meet with. That has to be managed by someone else. My job is to work with the team and find a solution to a business problem. So this is what you are going to need if you were to be successful. And this is what cost me one project, because I jumped straight to a project, starting working on it without having a domain knowledge expert there to talk to, without knowing where the data is coming from, without knowing anything about the data, without having a friend or data expert who can help me address any concern about data, without even having a start date and date of the project. I don't have anything. All I have is the manager wants me to work on this specific project. You know Python, go for it. And it costs me a project. So you need to have a team. So once we have a clear understanding of the business, then we are going to move into a data. So so we are going to design features we are going to need based on the problem. Then we are going to collect the data from different servers, different locations, different platforms, different shape, different structure, different type. We are going to read the data into whatever tools are or Python. Then we are going to manipulate or wrangle the data. We are going to apply some discovery, exploratory data analysis. We are going to apply some data visualization, building histograms, building bar plots, building line plots, building scatter plots, building heat maps, building an unlimited list of graphs that we can use to help us understand some of the hidden things that we wouldn't be able to discover by looking to the numbers themselves. Then we need to apply some statistical analysis, and finally we need to design a quality book. A quality book is simply a technical representative or a technical description of what you have in the data. And this is what we this quality book is what we are going to use for data preparation. In data preparation, we are going to look for outliers, missing values, outliers, duplicate records. We are going to fix target variables in balance or it's not normally distributed. We are going to look for hierarchies and cardinalities. We are going to learn how to transform categorical data into numeric, how to convert, how to transform, how to normalize, factorize, binarize, standardize, how to apply correlation analysis, how to aggregate and wean, how to decompose, and finally how to extract some new features or how to select features. And if once we apply these methods or some of them or one of them, then we are going to have a new version of the data. We started with the raw version and now we have a better version. And this versions is what we are going to use in the modeling. In the modeling, we are going to select models based on the analytical approach we already determined from the beginning. Then we are going to split our data into 80%, 20%. We are going to scale our data. Then we are going to apply or determine the dummy model. We are going to build a model. We are going to train the model into 80% of our data. We are going to test the model into 20% of our data. We are going to pair, determine or calculate the accuracy of the model. And we are going to do it for many models. And at the end, we are going to keep only one best model. And then one best model, there's always rooms for improvement, for optimization, and through optimization and parameter tuning. And at the end, we are going to have one best model with the best parameters. And this one best model with best parameters is what we are going to get into deployment. And once we deploy the model, we are waiting for return of investment, which is simply what we have designed or defined in the beginning. So this is your day-to-day activity as a data scientist. It's all fun. Nothing stressful so far. I've never felt stressful since 2014 working in data science project. All fun, all beautiful life. Okay, questions, concerns? Questions, concerns, please.
For a model, when you build a model, do you go by like requirements? I'm just thinking about like a product. Like when you build a product, you have requirements for a model. Like what do you start with?
Yeah, we start with number one. Before you model is a solution. Before you think about solution, you need to think about the problem itself, and you need to think about the data that you are going to use for that problem. That is a requirement. And the requirement of the problem itself, the data, the requirement would determine the best model to use. There are many categories for models. There are supervised learning models, unsupervised learning. There are supervised classification modeling. There are supervised regression modeling. There are clustering modeling. There are unsupervised learning. The semi-supervised modeling. There are reinforcement learning modeling. There are many types of modeling. And to determine the model to use, you need to have a clear understanding, a crystal clear understanding of the problem and of the data given to you.
Okay, thank you.
Okay. Other questions, concerns?
Brother, what is data wrangling?
Is a method that helps you, lets you look into your data, like merging files, renaming, aggregating, binning. So, for example, if you have a data with 12 months sale, you got January, February, March, April, December. So you got the data like this. You got day 1, 2, 3, and 29. We got some numbers in there. So maybe this data is not in the format that we could use. So what we could do in data manipulation and wrangling is, instead of using 12 months, we could use a total. We could use one column, and the column called total sale. Total sale, and we have some value. Instead of using 12 columns, we are going to use only one column. That is done through data manipulation and wrangling. This is simply one example. Clear? Other questions, concerns?
Question. So in the end, who determines if the data that we have is a good one versus a bad one? Who determines that? Do you get that after you go from point A to point Z? In the end, you have a solution and it doesn't work. That's where you know that your data.
That is a good question. Yeah, good question. You learn that along the process with your team. So with three of you should determine that. You will be driving. And sometimes you find something that does not click. You talk to your guys and determine if this is, let's say, for example, you have a column age. You got a column age, right? And you have a range. You have 19, 70, got 45, and you got 120. Got 120. One client has 120 years old. So for you, I mean, this, I mean, for the model, that is fine. But for you, this is not, does not make sense. So this is a wrong number. It could be a real number, but still we need to find out what is going on with this one client with 120, 120 years old. So maybe at the day of the data entry, the guy who was taking notes, was entering the data, he was very fast. So instead of typing 20, accidentally he did 120. It could be. But your job is find these animals and get them explained by the domain expert. You cannot continue with this data. You have to find an explanation of these deficiencies before you proceed. So you are going to discover
So, Brother Mo,
quality. Please hold on, brother. You are going to discover the quality of your data along the path. But the moment you discover something, you got to stop and get it clarified if you have a data expert within your team. Otherwise, you are screwed. Okay?
So basically, you're looking for
Yeah,
outliers in your data.
brothers, user, please hold on, brother. Suhaib, are you clear?
Yes, I'm clear. So suppose this column is age, right? So you know that this is an outlier. Let's say, for example, the example that you took, right, for the column of
Yes.
column age 20. But suppose you're working in an industry where you don't have a clue about what is right and what is quality and what is not. In that case, you are suggesting that we have a domain expert and they would guide us.
Even
Data science, they guide us.
Yeah, even you know your data, you still need to have a team. And within your team, you need to have a data expert. Regardless, you have to have a team.
Okay.
Don't wait until you have a problem and start building your team. You have to have a team from the beginning. And this team, it might not be full-time. So you are going to be a full-time data scientist, and they are going to be full-time, part-time your team. They have the other responsibilities. But whenever you want them, they have to be available. You don't have to.
Yeah, because if you make a team and then later on you're working on a different project where you don't have the expertise, so that means you'll have to pull in some other people who have the expertise.
Especially in the we're talking about expertise here in the domain and the data. You are gonna lack experience when it comes to the domain and when it comes to the data. I am working for a project right now as we speak. I have no clue what is the data. No clue. The data is so. Imagine in the data, I have 0. In the age, I have 0, and I have 120 in the age. Imagine where you're working.
Yeah, those are the two outliers in the age, of course.
Yes, it's not about outliers. About why, what happened, where this 0 is coming from. We need to find out what is causing this 0. Was it a typo? Was it a missing? So you could be exploring, grabbing, gathering this data from different resources, and you could be using, a script, a SQL script, to calculate age, the data for, hard date, your age, and live date. And if you don't have one of these data, you are going to get 0. It could be anywhere. It could be anything. But your job as data scientist, number 1 is to find them. Number 2 is clarify them. Why we have a 0, why we have 120. Then number 3, make a decision on them. Can we leave them? Can we remove them? Can we normalize them? Can we ignore them? So number 1, you need to find them. Find these problems. Number 2, you need to have an explanation. Why we have 120 in age, why we have 0. Number 3, make a decision. Number 4, and I forgot number 4, but yes, there are number 4 and 5. Now the problem, find them, get an explanation, make a decision, and fix them. Number 4 is fixing. Okay, Suhaib?
Thank you, Brother Mo. That was a great explanation. Thank you.
You're welcome. Okay, Khalid, I know you have a question.
I think I got my answer. Basically, my point was that we have to look at outliers and then either find an explanation to keep them in the model or exclude them from the model. Otherwise, our results may not be.
That is true, brother. And when we are dealing with outliers, just be careful. When we are dealing with outliers, so I'll give you an example. So let's say that we have a column that is salary. So this is salary, and you got 200 employees in the company. Okay. So we got the data scientist is making 180. We got data analyst making 90. We got DBA making 120. We got manager making 190. We got a freshman making 40. We got CEO making 1 million. We got someone else. Yeah, this is one example. The second example is age. And this is employee's age. We got 19, we got 170, we got 40, we got 19, we got 27, we got 0, we got -5. Okay, there are two types of problems here. One of them is real. Yes, we have a CIO is making one. This is an outlier, but it's a real outlier. We have that in the data. We have someone is making 1 million, right? So we have to treat this animal here different than the way we are going to treat the 0 and the -5 and 170. So these are outliers, but they are not real. They are outliers and we don't know the cause. It could be a typo, it could be transformation issue, it could be a missing values issue, it could be so many things. So once we find these animals using discovery, so we are going to find them using the exploration and discovery, basic statistics, ANOVA, MANOVA, mean, median, mode. We can use this exploration to find these problems. So number one, we need to find them. Find them. Number two, explain them. Number three, make a decision. Number four, then implement or take the decision or fix. And number five, you need to check the fix. Is the method, like for outliers, there are many methods to take. Number one, we could delete. Number two, we could ignore. Number three, we could impute or we could normalize. Number four, we could standardize. Number five, we could so many things. So which one is better? So once we find the outliers, we are going to explain them, and we are going to make a decision. Then we are going to fix them, and we need to check that fix. So maybe we deleted, and when we check, it did not click. So we need to kind of bring it back and ignore it, or normalize it, or standardize it, or or scale it, or do other methods. So these are why you need the process of fixing or looking into the quality of your data. And this is a team sport. You have to work with the team. Otherwise, you wouldn't know what you are doing, and you might be doing something stupid. Okay, Khalid?
Yes, thank you very much. Got it.
You're welcome.
Yeah, but the question: what is the difference between normalized and standardized? Aren't they the same?
It's simply they are using two different mathematical equations. So they are doing the same. They are doing pretty much the same thing, but mathematically they are different. Normalization, we are taking the x minus x, the minimum of x, divided by the maximum of x minus the maximum minimum of x. So this is the normalized. So you got an age, for example. We got age, we got 19, we got 20, we got 5, we got 7, we got 170. To normalize it, well, let's normalize 19. We are going to do here 19 minus the minimum of age is going to be 7 divided by max, which is going to be 170 minus 7. That is the normalized for 19. And we are going to do for the 20, we are going to do 20. For the 7, we are going to do 7. For 170, we are going to do 170. For the standardized, we are going to use the x, which is 19, minus the mean, divided by, I believe this is standard deviation. Probably. So they are the same. Normalization and standardization. It is going to reduce the numbers, the values, and it's going to make it either between 0 and 1 or minus 1 and 1 or minus 3 and 3. So instead of having 19, we are going to have a value between minus 0 and 1. 20 is going to be a value between 0 and 1. 7 is between 0 and 1. 170 is going to be 0 and 1. And now we don't have an outlier anymore. Okay, brother?
Yep. Thank you. Thank you very much.
You're welcome. Other questions, concerns, please?
Yeah, I do have a question.
Yes, sir.
So going to the, data scientist, the whole process. So looking at the business requirement, is it important? I know like we would have business expert, but is it important as a data scientist to have like a business expertise or just to focus on some of the areas where you have the project experience or something?
Honestly, and I'm going to share something with you. So to become a superhero data scientist, this is what you are going to need. If you want to be a superhero data scientist, and this is what you need to work on. You need to come with some expertise, number one. And if you don't have, then you need to work on it. So if you are working in healthcare, just stay in that domain and add analytics into it. If you are working in sales, stay there and add analytics. If you are working in finance, IT, management, accounting, transportation, media, gas station. If you are working in gas station, you are the owner of gas station, stay there and add analytics into it. Whatever discipline you are working on it, just stay in there, mastery, stay in there and add analytics. So that is one thing. So if you have that domain expertise, it's better. If you don't, then there is where the team comes into the place. You need to have a team. And trust me, regardless if you are a domain expert or you don't, you always need to have a team. Number two, you need one programming language, either R or Python. Number three, you need to know some mathematics and statistics and probability, something to help you make sense of your data. You don't have to be an expert. Number four, you need to know how to speak and explain the big words, these terminologies. There are 500, 600, 1,000 terminology in data science that you need to master. And you master them, you know them, you explain them through practice. And finally, you need to work on some projects. I need to see some problems that you fixed in the past and I need to see what the value you would bring to the table if I were to hire you. But it all starts with the domain experts.
Got
Okay.
it. Thank you. One other question is, related to cleaning. Do we start from like a source data where it's a raw data for data science, or and most of the companies, if they are already doing analytics and they already have a clean data available in somewhere in their data warehouse, data lake, whatever it is. So do we source it from there, or do we just work on raw? And if we are working, do we clean all the data, or whatever the subset of data which is required just for our data science needs?
So good questions, brother. Thank you so much for asking these great questions, and we are going to cover them. I promise we are going to cover them during the second phase of the CRISPDM. We are going to talk about them during phase number 2, and that is
Okay.
the understanding. But how do you handle that? Few things. Number one, and this is simply my own experience. I'm working for a company in New Jersey, and I'm already given data, already good to go data, clean data. But honestly, I went and I created my own data from scratch. I want to make sure that I am doing everything as I understand it. I'm doing everything correct and right as I understand it. If you are that data analyst, how sure I am you did what you did right. So I'm not saying that what you have done is wrong, but I need to make sure that you are doing it. You have done it right. So, and if I don't have you there to answer my question, I would simply go and design my own data. And let's say that in your data you have something like in your data you have let's say you have a million of records. So you have a data set that looks like this. You got 6 million records, and you got 300 plus columns. So you got columns, 300 columns. You got 6 million records. The question is, do we need to clean all the 6,300,000, or do we need to clean only the data that we know? At this point of time, we don't know what we need and what we don't need. No way. We don't know what we need and we don't know what we don't need. So a few things to start with. So we are, of course, we'd love to keep, we are gonna keep this 6 million, because the more records that we have, the better. But the more columns, the worse. So we need to reduce these columns. It's called dimensionality reduction. Sorry guys for the typo. Okay, there are few things that we need to start with. Number one, we are going to remove anything that is too much personal information. Like what? Like names. Who cares about your names? Who cares about your phone numbers? Who cares about your email address or physical address? Who cares about your social security number? It's too much information, too much personal information. Just get rid of them blindly. Number two, we are going to remove anything that is ID, like transaction ID, customer ID, student ID, anything that is ID. Why is that? Because these IDs, they are simply random numbers. They will not add any value to analytics. So this is a few things that you need to start just from the beginning. Number 3, we are going to remove anything that is constant. Imagine you have a column called age, and all your 6 million, they are 19, 19, 19, 19, 19, 19, 19, all the way to the end. You got one records, but if you have the same value, just remove it. It's not going to add in. It's a constant. It does not change. Number 4, we are going to remove anything with high cardinality. High cardinal. Like for example, you have a city, you have a zip code. Okay, city, the total, you have 500 cities, and zip codes, you got 3,500 zip codes, for example. So I mean, we got a lot of unique values for zip codes and a lot of unique values of the cities. So we might need to remove both. But we might, if we were to remove both, we are going to remove some information. So what we could do, instead of removing zip code and city, we are going to make a feature. It's called state. If we have 500 cities and 3,500, we could transform everything into 51 or 52 states. And number 5, we are going to remove anything that is data. Anything anything that is date, unless we are working on a time series analysis. So this is few things that you need to do on the fly before you start reading your data into whatever tools. Just remove anything that is too much personal information. Remove anything that is in IDs. Remove anything that is constant. Remove anything with high cardinality. Remove a date unless you are working on a time series. And the answer to your question, if we have a data like this, of course, we cannot start analyzing it. If we were to read 6 million records and 300 columns, the process is going to be very slow. You could crash your system.
Mo, a quick question. So you talk about.
Please hold on, brother. Let's make sure the brother asking the question is clear. Then I'll give you a chance to ask your question.
Yeah, brother. Thank you.
You're welcome. There we go. Okay, Horam. Mr. Horam, what is your question?
Sorry, it's Imran. So my question is, sorry. So you said that the cardinality, by cardinality, we can remove like city and zip, and we can put them in a state. But what if later on some stage we need that kind of information? We have lost it, so we cannot reclaim it back, right? So we have to know the requirement and problem statement before we apply the cardinality rule.
That is true. That is true. But if I'm telling you, if you asked me, Mohammed Wani, what is your location? If I say Atlanta, it's the same if I say Georgia, right? I'm in Georgia, I'm in Atlanta, they are the same, except Georgia is more specific, and Georgia is broad, and the state, the city is very specific. So in other words, you have the same information with different type of detailed information. So before you make a decision, if we have zip code and you have city, then we are going to eliminate zip code, because the same information we are going to get for the city, we are going to get from the zip code, except zip code could be more detailed information compared to the city. If we have city and state, the same information you are going to get, except that the city, you are going to get specific information compared to the general information used in the state. So, and before you make a decision, yes, you need to consult your team. the domain and see if probably doing this could could create a risk of losing information.
And once we lose the information, there is no way of reclaiming it other than restoring the older information, right?
You are going to go back to your data. No, and as data scientist, your job is to keep trying. Okay, now we are going to build a model with zip code. We are going to remove zip code the city. We are going to remove city and the state, and we are going to remove 3 of them and keep trying until you find something that is meaningful to you, is does address the concern the business you hired you for. So we don't know what is in the data, and we don't know what is the best way to handle this unless we try. So we need to keep trying and trying and trying until you find something meaningful.
Got it. Thank you.
You're welcome.
Hi Mo, I have one quick question.
Here we go. We have one sister talking. Thank you.
Yeah, my question here is like, how do we know the quality of data, and is it necessary to check the quality of our data after cleaning or wrangling and whatever, like, whatever the steps you have mentioned, like, like deleting all the like personal information, something like that. So is there a way that we can check the quality of the data, and is it necessary to do so?
So in terms of quality, it depends on what you are talking, what you define the quality. If you are talking about missing values, there is a way to find that. If you are talking
Yeah.
about outliers, there is an easy way to find that. If you are talking about duplicates, it's easy to find that. If you are talking about a hidden, unknown mathematical relationship inside your data, it's hard to. I mean, there is a process.
Yeah, that is my point. Like hidden, like whatever the mathematical data or something.
Yeah,
like
we are going to cover that, but it requires a lot of effort. So finding outliers, finding missing values, finding duplicates is easy.
Okay.
But finding wrong correlate or wrong what you call relationships, it's hard.
Yes.
So we are gonna dive deep. We are gonna investigate deeply. We are gonna dive deep into the data. So finding outliers, missing values is the surface. Anyone, my child could do that. Anyone could do that without any prior knowledge. But finding the inside or the hidden or the underlying structure and underlying problems, that requires some skills, which we are going to acquire during the program, and they are easy once we learn them.
Oh, okay. Thank you.
You're welcome.
Brother Mo, Shoaib, so one question about the data. You said being a data scientist, we need to love our data, right? So suppose we were talking about a consensus within the US or maybe world population or whatever. That means we are running into millions and billions of fields or data equipment. So every time we have to go back to the data, what would be the most efficient way to handle the data if we were to go back and look at some of the data that we want to go back, like take out the zip code and we want to go back and look at the city, or take out the city and go back and look at the state? How would we handle all this massive amount of data? Would that be handled by the program, or would it be more of a visual thing, or how would you handle that?
Again, it depends. It really depends on the company you are working for. It depends on scenario. It depends on why you have. It depends on your team. I do it myself. So once you have a data, it's called historical data. It's no longer in production. So you have it as a flat file. You have it in a location that you can always go to. And if you are afraid that you might change this historical data, make a copy of the data and play around the copy, delete, add, modify, edit. And if you feel like you did something wrong, go back and make bring a fresh copy. So there's a lot of ways to handle it. It depends on situations that you are struggling with.
No, but if the amount of data is very large, it's probably next to impossible to touch the data and then make any changes and go and look.
If your data is large and you will have to struggle with that. So one option is to do sampling. So let's say that this is all your data. And this is, let's say, 100 million records, and you got 5,000 columns. So it's impossible to use my laptop. It's impossible to use my laptop. So what we could do sampling. So we could do one sample randomly, then we could do another sample, random sample, then we could do another sample, we could do as many samples as we want. So if you have larger data, you know that you cannot handle it using the given infrastructure. You always need to do the sampling. And once you have a sample, of course that sample might not represent the population, and then you apply whatever you need to apply to that sample and use that sample to build your model. And always have a chance to go and fix or undo what you have done to your sample. So if you have larger data, stay away from larger data. Just get a sample. And what I mean by larger data is a data that cannot be processed using the infrastructure given. In one of the projects that I worked for, I had 6,000, only I think 600,000, 600,000 records, and I believe it was 300 something columns. And guess what? It crashed my system multiple times. So the moment and whenever I read it, it starts crashing. It's taking very slow. Then all of a sudden it crashes. And I was using Mac, newest version of Mac, but it still did not handle this 600,000 records. So what I need to do is I'm going to sample it.
Yeah. And you also said of the things you need to know Python or R, but could this thing also be handled by Excel, Microsoft Excel, or that would bring down the system?
Excel, you could do R, you could do Python, you could do Java, you could do C++, you could do Power BI, you could do Rapid Miner, you could do SAS Enterprise Miner, Watson Analytics, you could do Azure Email. There are many tools they could use.
No, I'm saying, can we leverage with Excel also, or no? Excel,
Yes,
Microsoft
but
Excel.
Excel has a limitation. Excel has a limit.
Okay.
Yeah.
Okay.
No, quick question, sir. So we have talked about that there are anomalies in the data, and we have techniques to correct them, but it is possible that sometimes we may overcorrect them, or sometimes we still leave some anomalies in the data, and that results that ends up in errors in our result. So what is the fault tolerance or risk tolerance when you are presenting your model or deliverable? Is it depending on the industry where you are working, or you give a disclaimer that, hey, 10% of data may be incorrect?
Honestly, this is a good question, and the answer depends on the sensitivity of the project you are working on. If you are working on a project that makes decision on a human, let's say that you are working for a hospital or for a pharmacy, and your job is to determine the side effect of a drug. A very tiny bias could kill someone, right? So there is no tolerance in there. The tolerance is zero. It's closer to zero. But if you are working on predicting my house, predicting my car, predicting if I'll be graduating next month, I really don't care if the tolerance is plus minus 10 or plus minus 50. I really don't care if you're predicting my house to be sold for 600,000 plus minus 50. So I'm going to lose money, but it's not life-threatening. So if it's life-threatening, the sensitivity or the tolerance should be zero. If you are working on in a non-human project, then it doesn't really. It's industry standard.
Got it. It means the massaging of the data before you start doing your modeling depends on what industry you are working. So how much time and you invest, how much money you invest in massaging the data and making it as accurate as possible depends on the industry to minimize your risk.
No, so again, the risk is all related to sensitivity. If it's life or die, life or die, that is then you need to minimize the tolerance.
Got it. Thank you, sir.
So if you are working on a business, you want to make a decision either to buy or make. That's live or no. If you buy or make, then the tolerance should be minimum.
Got it.
You're welcome.
Thank you.
Okay, folks. So unfortunately, we are talking about data, which we are going to cover next week. So let's move on. So you are going to need in the team. You are going to need three. You are going to need three experts. You are going to need domain expert. And you are going to need data expert and you. So data science is a three-legged stool. Imagine that you are one stool or one leg missing. Of course, the stool is not going to stand. It's a table. If one table with three legs, if you have one leg is missing, the table is not going to stand. So we are going to have data scientist, which is you. We are going to have a data expert. We are going to have a domain knowledge or data analyst. Then we are going to have the architect, application architect, someone who is going to help us to deploy the model layer and the production. In terms of the distribution, understanding the problem, you have to be there. And of course, you might need to call your architect to be with you because he's the guy who's going to help us to deploy the model into production if the model is going to be in needs deployment. So once we have a clear understanding of the objective, the problem, then we need to get the data. So with the data, you are going to be there, and the architect has to be there also, and we need to call in the data expert to help us clear out any concern we have in the data. Once you move on with the data, now we are going to prepare your data. You need to prepare, pre-process, clean, manipulate, explore. Then you are going to be there as data scientist, but we are going to need help from domain, business, or data analyst. Then training a model or building models, or you are going to be there by yourself. This is where you are going to apply machine learning, deep learning, NLP, big data, artificial intelligence modeling, name it. So once we have a model, then of course we need to deploy the model, and I don't need to be there. So this guy should be there to deploy the model for us. And finally, when we want to update the model, you have to be there. So your life is your existence is important throughout the entire analytical project, and the team, the part-time member of your team, it's as needed. So the architect, we are going to need him, and the data understanding, and data business understanding, data understanding, and the deployment. Okay, folks. So a lot of information. I'm going to skip this, and I believe that's it. That's it. A lot of information, and we talked about this. So, any question, concerns, please?
What is the role of the project manager, and can the data scientist be considered the project manager also, being that they are ever present for the life of the project?
Project manager is the person who is responsible of conducting the project from the beginning all the way to the end. He's managing the entire project, and within that project, we have you as the data scientist. They have me as data analyst. They have Ali as domain expert. They have let's say Imran as something else. Asad, please mute yourself. Asad,
that was my question.
Asad Zaki, please mute yourself. So
Yeah, that
yes,
was my question, brother.
yeah, sorry, my apologies. Yeah, my apologies. So yes, you could be a data scientist and a project manager at the same time. Now managing the project and working the project, you could do that. But trust me, once you know to be a data scientist, just focus. Just be a data scientist and stay away from being a project manager. Give that responsibility to someone. I don't have time. If you hired me as data scientist, I really don't have time to go look for someone to talk to in terms of how to get a data. Give me access to this server, or who's need to get to whom do I need to talk to about a problem. We have to have a project manager who can facilitate that things for us. Otherwise, you are going to spend a lot of time talking unnecessary talk. So we want to get to the point, and start fixing problems rather than wasting time or trying to find how to fix problems.
Okay, got it. Thank you.
Okay, let's take 5 more questions and we should stop. 5 more questions.
Assalamu alaikum, Brother Mo. I had a question about this three-legged stool example you talked about. So, hypothetically, let's say you're working with another team member who's responsible for the data gathering, and they come up with a question about certain SQL scripts or something that is very particular to that person's skill set. Now, I mean, I'm being a data scientist and knowing all the statistical methods and the mathematical formulas. Have you run into any real world scenarios where somebody can say, "Oh, well, Brother Mo, how come you don't know that?" Well, I mean, you should be knowing of data modeling. Do you run into any kind of scenarios in your
Yes,
projects?
I did. I did. And as a matter of fact, I will share one story with you, and we'll talk about this. In one of interview I had, I believe I did a great job explaining the situation, and I know myself. I know my capabilities. I know my skills, and the feedback I got, this guy knows nothing. So I submitted I went through the interview, everything went fine. Then they gave me a take-home test, which is 24. They gave me a problem data and a couple of analytical questions they want me to answer within 48 hours. I did and submitted that, and the feedback I got from them is I know nothing. And yes, so that is one case.
Really?
Yes.
Okay.
So I really don't care, because I know myself. Another scenario that one guy was interviewing me from in California. And by the way, in the last 5 years, I had more than 150 interviews. More than 150 interviews. I was not looking for a job. I was simply trying to understand what these hiring managers are looking for in a candidate and transform that need into the program I'm teaching to improve it. So this guy, after I introduced myself, he introduced himself, then he said, okay, let me ask you questions. Then he Googled, and I know the website he went to because I've been searching, and he was asking me from that website, okay, what is decision tree? Okay, what is this? What is that? What is that? Okay, in terms of your question, so you are always going to find some people out there that are mocking you, putting you down, or they are jealous. They don't want you to be better than them. And of course, if I don't know, I don't know. But yes, sometimes they were expecting me to know everything. No, I don't know everything. I am not a SQL. I'm not a database, expert. I don't know how to. I know how to fetch my data, but I don't know how to update a table. I'm going to tell them, this is not what you hired me for. If you don't like it, I'm done. I'm bye bye. That's it. Yes, I mean I have that scenario where they question my ability to do something, but this is not what I've been hired for. I am
Thank you, Brother
a
Mo. Yeah.
scientist. So and
So,
don't
so
be,
from
yeah,
so for
don't be afraid to face it. Don't look at yourself and don't no, don't look yourself down if someone puts you down. I did.
Understood. So basically, the takeaway that I'm getting from what you explained is that I should be responsible for what I know of, and the other team members should be responsible of getting me what I need to do
Right.
my job.
That is
Got
exactly
it. Okay.
yes. in big data, let's say that I'm working on a big project and big data, I'm going to tell them I am not a big data guy. I know nothing. Cloud, I know nothing. Don't ask me. This is not my expertise. My expertise is to apply machine learning, deep learning, NLP on your data and transform your data into a product. So if you're asking me something that I don't know, then you got to train me, and you need to invest and train me. Then I'm gonna do my job. And always, this is all what always do. What always tell my managers is, I don't know, but I'm capable of learning if you give me the environment to learn.
Thank you, Brother Mo. I know you probably have 4 more questions for the other team members. I just wanted to ask one different, totally an observation that I've seen, and just to talk about a real life world scenario. The recent 2020 consensus that happened had a big bias in their data, right? So I just wanted to ask you. There's a lot of things that came out from the 2020 consensus. Obviously, there's a lot of big data, a lot of, data scrubbing and so much involved in that whole process. And, there were big undercounts with Black people, Latinos, and Native Americans that were undercounted in that consensus. So my question is, since it's being apparent that politics were involved and so many things were involved, and after when the numbers come out, it's apparent that a lot of money was wasted on certain things and things were not done right. So what you're saying is, in real life world, can we face a scenario where other factors can affect our job when we do the data scientist work that we are required to do? Can external factors affect our outcome of our data?
That is true, yes. And let me give you an example. Let's say that you are working for AT&T. Okay? AT&T and T-Mobile and Verizon, they are losing clients every month, right? I was in AT&T last month. I did not like it for a reason. Then I switched to AT&T. And you were in T-Mobile, you switched to AT&T, and he was at AT&T, switched to T-Mobile. So these companies, they are facing this problem is called churning. They are losing too many clients every month. So imagine they hired you as data scientist. They hired you as data scientist, and they give you a data of all the clients that they left. And you did your analysis, you did everything you could, perfect. Everything is perfect, but the outcome does not click. You are not you are not fixing your problem. So what could happen? So we use all the factors that we know we have in the data, but probably we are missing something that is maybe more critical, and that is a third-party factor. It could be our competitors, they are reducing their prices. It could be our competitors, they are giving 2 phones free if you were to purchase one line. Of course, if you have a family plan with Verizon and you heard the AT&T is providing free phones, I'm going to switch right away, right? It's nothing wrong with Verizon, but there is something better from other competitors that we need to consider. So as data scientists, you need to consider third parties, the factors, unknown and hidden, latent factors that they are not in the data, but they are somewhere else. And that is where you need to bring a domain expertise into the picture. We have to have a domain expert who not only addresses these type of problems, but give us an insight, give us a clear picture, and guide us through the direction. We are going one direction. It could be the right direction, but we are using the wrong tools. We are using the wrong data. We are using the wrong assumptions. Clear?
Yes. Thank you, brother. Jazakallah.
You're welcome. So 4 more questions, please.
So Brother Mo, so one other question is, once you get into a project, they give you a problem statement, and they say the client says that this is what we expect to as the outcome, but then when you cannot commit that that outcome is going to meet or not, right, until you analyze the problem in detail and come up with a solution. So what happens in that scenario where once you analyze, you say that, maybe some of the problem can be fixed, but some cannot. So how those, when it will be determined, what phase it will be determined, and how it will be tackled? And do you have some certain scenarios like that?
Sure, brother. So I recommend, this is one book I recommend for you all. It's called Data Science. Create a team that asks the right question and deliver the real value. And I have PDF. I'm going to share it with you. So this is a book that I recommend for everyone. Okay, so back to your question. Yes, there is always a difference between the traditional project, the traditional project and analytical project. In the traditional project, we have the start and end date. In the traditional project, we got start date and we got an end date. We got start date and we got end date. And in between, we have some deliverables. The first, we are going to deliver something, then the second phase, we are going to deliver, and etc. This is traditional project. Analytical project is we have the same thing. We have start date, and we are going to have end date. And most likely, it's going to be 6 months start date, and we have end date. The only difference between them is in analytical is in the traditional project. We promise that we are going to deliver something into the first week, second week, and 7th week, 17th week, etc. We promise. For the analytical project, it's hard to promise. It's really hard to promise because we don't know what to expect in the data. We don't know how good or how bad. We don't know even if the data is going to give us anything. So we are going to tell, we are going to help change the culture. If the business are used to traditional project, it's hard to change the culture. So, but we have to face it, to tell them it is really hard to promise you something, but we are going to analyze the data and provide the outcome. So whatever the outcome is, it could be at your favor, it could be against you, it could be not what you are expecting, it could be something else, but that is the data. My delivery is based on the data. I have all the skills, all the tools, all the modeling or the equation functions. They are already been tested in so many projects and they work fine. The only thing that changes is your data, and I don't know what the data is, what to expect from the data. So don't promise anything when you are working on an analytical project compared to the traditional project. Okay, brother?
Thanks. Thank you, brother.
You're welcome. 2 more questions, please. Okay, folks, so that's it for tonight. Unfortunately, I'm not going to be here next weekend, Friday, but my partner, Professor Ed Bujak, will be conducting a crash course in Python. Please make effort and join and learn. We are going to need that one session to help us conduct the remaining sessions. So it's really important that you guys join the Friday session. I am not going to be here. I will be in Dubai for a conference, so please pray for me, and I'll see you guys the following week. Until then, you guys have a great evening, a great Friday, a great weekend, and assalamu alaikum wa rahmatullah.
Wa alaikum assalam wa rahmatullah.
وعليكم السلام.
رحلة سعيدة محمد.